Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of object-oriented software engineering. We'll dive into key concepts like testing strategies and test cases for OO software process, project management, rational tool mentors. Introduction to design patterns. Let's get started. Slide 1. Testing strategies for object-oriented software. Testing in object-oriented software engineering (OOSE) follows a structured approach to ensure correctness, performance, and reliability. Unlike procedural testing, OO testing focuses on objects, their interactions, and system behavior. 1. Unit testing tests individual methods and functions of a class. For example, in an ATM system, the function to check account balance is tested separately. 2. Integration testing ensures that different modules interact correctly. For example, verifying that the ATM's authentication system works correctly with the transaction processing system. 3. System testing validates the entire application. Example: an ATM's full transaction process, including withdrawals, deposits, and receipts. 4. Regression testing ensures that new changes don't break existing functionality. 5. Acceptance testing, performed from the user's perspective to ensure system meets requirements. 6. Mutation testing introduces small changes in the code to check if tests detect errors. 7. White box and black box testing. White box tests internal code logic, while black box focuses on input-output behavior. Significance: OO testing ensures that objects and their interactions align with design expectations, reducing software defects. Slide 2. Test cases for OO software process. Test cases help validate software functionality. In OO testing, test cases focus on objects, their states, and interactions. 1. Class-level testing checks individual class attributes and methods. 2. Object state testing verifies if objects behave as expected under different conditions. 3. Message passing testing ensures correct data exchange between objects. 4. Inheritance testing confirms that derived classes function correctly. 5. Polymorphism testing ensures overridden methods execute as expected. 6. Encapsulation testing validates access control to private and protected members. 7. Concurrency testing checks system stability under simultaneous object interactions. Example: in a payroll system, test cases may verify whether a salaried employee receives the correct monthly salary calculation. Significance: helps detect issues in class behaviors, object communication, and system performance. Slide 3. Project management in OO software engineering. Project management ensures that software development stays on track, within budget, and meets quality standards. 1. Requirement analysis, defining clear goals and functionalities. 2. Planning and scheduling, creating timelines for different phases. 3. Resource allocation, assigning team members and tools. 4. Risk management, identifying potential project risks. 5. Quality assurance, ensuring software reliability and performance. 6. Monitoring and reporting, tracking progress and identifying issues. 7. Maintenance and deployment, ensuring post-release support and updates. Example: managing an online course registration system requires tracking development stages, assigning tasks, and handling risks. Significance: structured project management leads to timely, high-quality software delivery. Slide 4. Rational tool mentors. Rational tool mentors provide best practices for software engineering, helping teams efficiently design, develop, and manage OO projects. 1. Rational Rows, a UML modeling tool for designing OO systems. 2. Rational Unified Process (RUP), a structured methodology for software development. 3. Rational Clear Case, a tool for version control and configuration management. Point 4. Rational Requisite Pro, manages software requirements. 5. Rational Test Real-Time, automates real-time software testing. Point 6. Rational Performance Tester, ensures software meets performance expectations. 7. Rational Functional Tester, validates software functionalities. Example: Rational Rows helps visualize ATM system design before implementation. Significance: these tools enhance software quality, efficiency, and collaboration in large-scale development. Slide 5. Introduction to Design Patterns. Design patterns are reusable solutions to common software design problems. 1. Creational patterns manage object creation, e.g., singleton, factory method. Point 2. Structural patterns define object relationships, e.g., adapter, composite. 3. Behavioral patterns handle communication between objects, e.g., observer, strategy. Point 4. MVC, Model View Controller, separates OE, data, and logic. 5. Decorator pattern, dynamically adds functionality to objects. Point 6. Facade pattern, provides a simplified interface for complex systems. 7. Proxy pattern, controls access to another object. Example: the singleton pattern ensures only one database connection exists in an application. Significance: design patterns promote efficient, maintainable, and scalable software development. Slide 6. Advantages of using design patterns. 1. Improves code reusability, reduces redundant code. Point 2. Enhances code maintainability, easier debugging and updates. 3. Standardized solutions, provides industry-accepted best practices. Point 4. Encourages scalable design, supports future growth. 5. Reduces development time, saves effort in problem solving. Point 6. Improves communication, helps teams understand system architecture. 7. Ensures flexibility, allows modification without major code changes. Point 8. Promotes best practices, encourages use of proven coding techniques. 9. Enhances system performance, optimizes resource utilization. Example: using the factory pattern in an e-commerce system ensures efficient product object creation. Significance: design patterns lead to well-structured, scalable, and maintainable software systems. Slide 7. Summary. 1. Testing ensures correctness, reliability, and functionality of OO software. Point 2. Test cases focus on object interactions, state changes, and inheritance. 3. Project management organizes software development from planning to maintenance. Point 4. Rational tool mentors streamline design, testing, and collaboration. 5. Design patterns provide proven solutions for building robust software. Point 6. Applying these techniques together results in efficient, scalable, and maintainable software. 7. Real-world example: a banking system applies OO testing, project management, and design patterns to ensure security, usability, and performance.